Hi everybody, Mr. Rubo here, and today we are continuing with 2.1, and we are now going to talk about geometric sequences. So arithmetic, you had that common difference, right? It was very linear in their pattern. Now we're going to look at geometric, which these ones, their successive terms have a common ratio, or they change proportionally each time, a constant proportional change. So kind of similar to arithmetic, there are two ways of writing their equations. You can either write g sub 0 times r to the n, and just for the sake of seeing it, g sub 0 is kind of like how a sub 0 was. It is that initial value. And then r is the common ratio. Right. The other way you can also write it is kind of similar again to the arithmetic. You can have a specific term, so the kth term here, g sub k times r to the n minus k. And again, this would be the kth term of the sequence. Okay. Now, geometric sequences behave more like exponential functions, except again, they are not continuous. They're just made up of points. Now, increasing geometric sequences increase by a larger amount each step. So, but the percentage that they're increasing always stays the same. So you're going to see here what I mean by that. So here's an example of a geometric sequence. And if I wanted to plot this, I'm going to go the table route, and again, you'll kind of see if you understand this. It won't take you as long, but I'm just going to go ahead and do 0 through 4, again, because it's a sequence, so I cannot do decimals. So I'm going to start plugging in, right? So 1/2 to the 0 is 1. 1 times 8 is 8. Then 8 to the 1/2, 8 times 1/2 to the first. Well, that means I'm doing half of 8, which is 4. Then 1/2 squared. 1/2 squared is 1/4. 1/4 of 8 is 2. 1/2 to the third. Oops, that's supposed to be an 8. Is 1/8. 8 times 1/8 is 1. And then 8 to the 1/2 to the fourth. That would be 1/16. 8 divided by 16 is 1/2. And you can hopefully see kind of the pattern that is occurring here. But yeah, so let's go ahead and plot this. So 0, 8 starts up there. Then at 1, we're at 4. 2, we're at 2. 3, we're at 1. 4, we're at 1/2. And this is a good point too. So sequences, again, as you saw in the last video, the input has to be whole numbers, but the output can be whatever. So you can see here it's a 1/2. But if we kind of keep seeing this pattern, you'll end up with like 5 would be 1/4. Okay, then it would be 6 would be 1/8, right? We could keep plotting, but hopefully that kind of makes sense. All right, so right now we have we're looking to see for this next example, if just is the sequence geometric. Okay, and if it is, identify the common ratio. So the one we gave here was a geometric sequence, and if you notice, going from 8 to 4, then 4 to 2, then 2 to 1, I'm multiplying by 1/2, which is that common ratio that we knew was there based on our equation, right? So r was the common ratio. Not Rashan. Whoops. So 1/2 is that common ratio, so that's what I'm multiplying each time to get my next value. So now I want to just see, well, for the sake of these notes, I'm going to do tables of values and see, is this value, or is my outputs being multiplied by the same thing every time? So I'm, again, going to go 0, 1, 2. I'll go all the way to 3 for this first one. So 3 times 0 squared is 0. 3 times 1 squared is 3. 3 times 2 squared, sorry, my 0 there is really ugly, is 12. And 3 times 3 squared is 27. So from here to here, it's not even like times 0 by anything is going to give me 0. So that already I know it doesn't work. But just for sake of argument, that's times 4, and then this would be times 9/4. These are not the same, and also the first one you can't even do the multiplication, so not geometric. All right, and then let's keep going. So the next example, again, you could possibly tell just based on the equation, but for the sake of this video, I'm going to go ahead and do table of values. So 0, 1, 2 I'll do in this case. So I got 4 times 2 to the 0 minus 1. 0 minus 1 is -1. 2 to the -1 is 1/2. 1/2 times 4 is 2. Then I'm going to do the same thing. 4 to the 2 to the 1 minus 1. So that's 2 to the 0, which is 1. So I get 4. And then, 4 times 2 to the 2 minus 1. Well, that's 2 to the first. 2 to the first times 8. Times 4 is 2. 2 to the first times 4 is 8. There we go. And now we can already see I'm multiplying by 2 each time. So it is geometric because we're multiplying by the same number every time, and our common ratio is 2. Again, you kind of could have told by this one just because of the fact that, hey, it was written in that format up here. Okay. So let's look at the next couple where they're not in the equation format. So here we're just kind of looking at how do I go from one number to the next using multiplication. So that's times 3. Ooh, that would be not times 3. So I can actually stop right there. It'd be times 2/3. And I don't have to go any farther. It's not geometric. And there we go. It's got no common ratio. Okay, now this one, even though you see some like positive and negative switching, that doesn't tell you exactly. You have to make sure, again, you're looking for how would I multiply, what do I need to multiply 16 by to get -8? Well, that would be -1/2. Then to go from -8 to 4, multiply again, -1/2. 4 to -2, multiply by -1/2. And the last one, I'd multiply by -1/2. So this indeed is geometric. And my R is -1/2. Oh, my pen stopped writing. There we go. And there you go. Okay. So yeah, again, geometric multiplication of the same number over and over again. The R value can be positive or negative, like we saw in this case of the -1/2. All right. Thanks for watching. Have a good day.